Hello students, my name is Vipul and I teach mathematics to class 10th, 11th and 12th. I started giving tuitions when I was in class 11th and since then I have taught around 30 to 40 students. So you may see some sticky notes and notes above the whiteboard, but please ignore them because they are the part of my studies. So let's start with the topic and please be with me for some few minutes so that you will know how I teach. So starting with the very first topic, or you say very special topic of mathematics, that is trigonometry. I personally love this topic. But before starting to getting know about this topic or learn this topic, we should know why are we learning this topic, what is the need of it, or what are the practical application of this. Practical application. Coming to the practical application, trigonometry is used in the field of physics. Trigonometry is used in architecture, navy, and also army, aviation industries, marine biology. There are n number of applications of trigonometry. If you count them, they are countless. But trigonometry plays a very important role. So yes, we should learn it. Now second, let me give you a very simple example that will explain you the need of trigonometry. Suppose you are on a boat in a sea. This is the sea. This is your boat. My drawing is not that good. And you see a light, a top light when you are sitting on a boat. But you don't know how far that light is from you, that is this distance. And you can only see this, the top light of that lighthouse. But if you wish to find the distance between the bottom of the lighthouse and your boat, or to the top from your boat, there comes trigonometry. This is angle theta. For example, your inclination makes an angle theta with this light. So with the help of trigonometry, you can find the height of this lighthouse. Obviously the light is a part of a lighthouse because in the sea there are only lighthouses. So you can find this height, you can find this distance, you can find this distance. So trigonometry will help you in this. Now coming next, how can we find this? What is this theta? This theta is angle of inclination. Suppose, I will rub this. Angle of inclination, that is angle of inclination, and angle of declination. There are two terms. What are these? Very simple, need not to have worry. Angle of inclination is, suppose you are here, you see a bird over here. See? Now if you look at that bird, this angle made between your eyesight and the bottom is theta, and this is called angle of inclination, that is upside. And suppose this is not a bird and this is you at the top of your house, or you say terrace, and you're looking down to some car. This is any car. So this angle made by your eyesight and the bottom is again theta, that is 1, and theta 2. And theta 1 here is angle of inclination. Theta 2 here is angle of declination. Clear? Angle of inclination, angle of declination. So this is what? This is angle of inclination. Very nice. Now coming back to the next. Trigonometry is based on ratios. Trigonometric ratios. What are trigonometric ratios? Okay, what is the simple meaning of a ratio? You know a ratio? Ratio, you can say something upon something. Very simple. I'll say trigonometric ratio is trigonometric ratios. What are trigonometric ratios? Let me name them. Sine, cosine, tangent, cotangent, secant, or we say cosec. These are the trigonometric ratios. Now, why are we calling them ratios? There's a logic behind it. See, sine can be understood with the help of this triangle. Okay, trigonometry is always applicable in right angle triangle. Only applicable in right angle triangle. I'll repeat this. Right angle triangle is where we have a right angle in a triangle. So, if this is the right angle and this is theta of triangle A, B and C, what you can see? Sine theta is always perpendicular upon hypotenuse. This is hypotenuse, the biggest side of a triangle. This is perpendicular, the side opposite to theta. Okay, and this is base. So, sine is perpendicular upon hypotenuse, that is this side upon this side. Very nice. Now, cosine, or we can say cos, is base upon hypotenuse, that is base upon h. Tangent similarly is sine upon cos. I'll say sine upon cos, that is p by h upon b by h. That comes p by b, that is perpendicular upon base. Tan theta is this upon this. Easy? Now, coming to the point, now it becomes very easy. Cotangent is opposite to this, secant is opposite to this, and this is opposite to this. So we can simply write cot is b by p, secant is h by b, and this is h by p. Clear? Trigonometric ratios with the help of a right angle triangle. Now, with the help of these trigonometric ratios, we have defined some trigonometric identities. What are the trigonometric identities? So, before going to the trigonometric identities, we should know how these trigonometric ratios behavior changes with the help of different angles. As we know, or we should know, that trigonometric ratios depict different values at different angles. For example, I'll show. I hope you must be aware of angles. That is, okay, if you aren't aware of the angles, I will tell you. This is complete Cartesian. 0 degree, 90 degree, 180 degree and 360 degree. It makes 4 quadrants. First, second, third and fourth. These 4 are quadrants. Trigonometric ratios have different behaviors at the different quadrants. So coming to the point, I'll write some angle that is 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. Put a line over here as well. Sine, cos, cosine we can write cos. Similarly tan, cot, sec, cosec. Now, these trigonometric ratios have different values at these angles. So what are these values? I'll tell you. Sine at 0 degree, that is the value of theta is 0. Sine 30, it is 1 by 2. 45, 1 by under root 2. 60 under root 3 by 2. 91. Cos at 0 degree 1. 30 degree under root 3 by 2. 45 same under root 1 upon under root 2, that is 1 upon 2. And at 90 degree cos theta at 90 degree is 0. Clear? Now coming to the tan, that is sine upon cos. You can write it from here as well. Tan 0 0. This is under root 3. This is 1 upon under root 3. 1 upon under root 3. This is 1. This will be under root 3. That is tan value at 60 degree is under root 3. And this is NA. NA is no answer, or you can say not defined. Now similarly, we can write the values of these three ratios, because as I told you earlier, that these are just opposite to these. That cot is opposite to this. Okay, let me show you here. Cot is equals to cot theta is equals to 1 upon tan theta. Theta is any angle. We don't care about this. Sec theta is opposite to 1 upon cos theta. Similarly, cosec theta is equals to 1 upon sin theta. Easy. Now similarly, we can write the values of these. Can we? Yeah, we can. So this is NA. That is no answer. This is under root 3. This is 1. This is 1 upon under root 3. And this is 0. For sec, please ignore my handwriting. I'm really sorry for this. Yeah. Okay. For sec theta, it is opposite to this. It will come 1, 2 by under root 3, root 2, 2, NA. Cosec, NA. 2 under root 2, 2 by under root 3, and this is 1. So these are the trigonometric ratios at different angles, and with the help of these trigonometric ratios at different angles, we have made some trigonometric identities, which makes our applications much easier and which helps us to solve all the trigonometric problems in very convenient way. For example, there are n number of trigonometric identities, but if I am giving a simple example, I'll tell you a very simple trigonometric identity, that is sine square x plus, or we can write theta plus cos square theta equals to 1. This is the identity. Now I have to prove this identity. How can I prove this identity? Let's take a value of theta. Sine, if I take theta equals to 0, theta equals to 0 degree. Now if theta equals to 0 degree, I'll put 0 over here in this equation. So sine square 0 plus cos square 0 equals to I don't know what. Okay. Now sine 0, this. Cos 0, 1. So 0 plus 1 is 1. Identity proved. Our answer came LHS is equals to RHS. Very easy. Similarly, this identity will follow for each and every sine value at any angle. If you say sine 45, you can add them. Sine this, you can add them. They will always come 1. There are similarly n number of identities for like cos square theta, cos 2 theta, sine square theta is equals to 1 minus cos square theta, tan square theta, tan 3 theta, and for different angles, triple angles, cubic angles. So these identities, as I said, help us to solve problems and do applications in much easier way. Okay, students. So this was all basic about the topic trigonometry, and yes, if you are coming with me, I will like make it sure that you will start learning from the scratch. I don't want any prerequisites. I don't want anything. I start teaching from basic, from here to here. But only one condition, that you need to work hard. That's it. Thank you very much. Goodbye.